right, next thing we're going to talk about is finding the intersection of two lines. Okay, so one way that we can do it is by graphing. Now this is typically not the way that that we do it, but it illustrates what we're actually trying to do here. So I have two lines. I have 3x plus y equals 5 and 2y plus 4 equals x. All right, now those are not in a nice form, so I want to solve this problem by graphing. And it would be easier if I rewrite these equations in slope-intercept form. So let's do that. Let's start with this first equation. If I just subtract 3x from both sides, then I get the equation y is equal to a negative 3x plus 5. Okay? And that's easy enough to graph because now I know that the y-intercept is 5, which is way up here, and the slope is a negative 3. So from that point, I can just go, I know the rise over run is negative 3, so I want to go down 3, 1, 2, 3, and over 1. And then that will give me another point on the line. So I'm just using the slope. So I go down 3 and over 1. And down 3 and over 1. And those will all be points that are on this line. Now let's see if I can connect those up and make a decently straight line. You get the idea. Okay, that's as good as that's gonna happen with this pen. All right, so there's my line. Now I want to do the same thing for the other line. So I want to get it into slope-intercept form. So I'm going to actually subtract, I got the y on the left-hand side, so I'm going to subtract 4 from both sides. So I get 2y is equal to x minus 4, right? Because I cancel these 4's. And then I'm going to divide everything by 2, or you could think of it as multiplying by 1/2. All right, but remember when you do this, you have to multiply all of both sides by 1/2. Or you have to divide all of both sides by 2. You can't just divide one part of it, right? So the thing here is that the 1/2 times 2 is just 1, and 1 times y is just y, right? So now we got y isolated, and now I'm going to distribute the 1/2. Okay, so I'm going to get 1/2 x minus 2. All right, so there's an equation for a line. It has a y-intercept of 2 and a slope of positive 1/2, which means the rise is 1 and the run is 2. So I can then use that to find other points. Okay, so this m equals 1/2 is a rise of 1 and a run of 2, or you could actually think of it as you could also think of it as a rise of negative 1 over negative 2. So rise of negative 1 and a run of negative 2. So that allows me to find points that are in the opposite direction, right? So I can go down 1 and over 2 and also find points. Down 1 and over in the negative direction by 2. All right. So now I've found a bunch of points. I can connect them with a line. Okay. And you can see that these two lines intersect and nicely at whole number coordinates. It looks like it's 2, negative 1. All right. So we want to find the intersection of the two lines. It's the point that is on both lines, right? So it's the point that satisfies both of the equations. All right. And you can check if you go back to the original equations and just plug in the x and y values. So the point where they intersect is 2, negative 1. So if I plug in those x and y values, the equation should be true, right? It should satisfy the equation. So so if I take 3 times x plus y, and that should be equal to 5, right? So 3 times 2 minus 1 is 5. So that works out. And I can check the other one too. 2 times y, which is negative 1, plus 4 should be equal to x, which is 2. So I have negative 2 plus 4 is equal to 2. Yep, that checks out. All right. So that point that we're looking for, the point where they intersect, is the point that satisfies both of the equations. All right. Now, like I said, we don't usually solve systems of equations like this. I just wanted to uh, do one like this so that to illustrate the point of what we're doing. All right, we're trying to find the point that satisfies both of those equations. All right, I'll meet you in the next video for the next example.